All right, so we are going to start our notes on linear transformations with a quick exploration. So in this video, I'm just going to do these first three examples, and then next class, I'll have a video for these situations. And so make sure you keep these notes so that we can continue at next class. And so right now we are comparing these two functions, f of x equals x and m of x equals 2x plus 5. And so first off, this f of x equals x, this is the linear parent function. Linear parent function. He's the parent function because his slope is just 1. There's an invisible 1 in front of the x. And his y-intercept is just 0. Remember, there's an invisible plus 0 if you don't have a b value there. And so to graph this, we would start at 0. And then our rise over run would just be up 1 over 1. Up 1 over 1. Then we can go back. And so it's kind of a boring line, and so that's why we call it the parent function. And then all other lines in y equals mx plus b, for example this one, are just transformations of this one parent function. And so looking at m of x equals 2x plus 5, let's switch to this color. He's got a y-intercept of 5. 1, 2, 3, 4, 5. So he's been shifted up from our parent function. And then he's got a slope of 2. So instead of going up 1 over 1, remember we can rewrite the slope. Well, I don't want to use m because they're using m for the function. So I'll just say slope of 2 is rise 2, run 1. Rise 2, run 1. And then if I go backwards, I would go down 2 and back 1, maintaining that slope. And so not only has m of x been shifted up, he's also steeper. And so to answer these questions, did the function get steeper or less steep? He is steeper. He's got a bigger slope value. The original slope of the parent function was 1, and then we switched it to a 2, making it steeper. Anytime you increase the slope greater than 1, it's going to be steeper. And so now it's asking what happened to the y-intercept, and it shifted up. Shifted up, how many units? 5 units. So the original y-intercept, was 0, and it changed to a 5, and so it shifted up. And sometimes instead of the word shifted, they may say translate, and so I'm going to put translate. Don't let that word scare you. Translate means shifted. Okay, and so I'm going to restart the video for example 2 just in case this crashes. All right, example 2. We are once again starting with the linear parent function with a slope of 1. And a y-intercept of 0. So I'm going to put him on the graph. Anytime you see f of x equals x, that's the linear parent function. The slope is 1. And the y-intercept is 0. You don't actually see those numbers because they're lazy and they don't write them, but you know they're there. Okay, this time m of x equals negative 2x. So it also has a slope, a y-intercept of 0, because there's no plus number. And so you can add that plus 0 after the x. And his slope is negative 2. And so again, we're going to start at 0, but this time we're going to go down 2 over 1, down 2 over 1, down 2 over 1. And if we go up 2, we would have to go back 1 to account for the negative. Anytime you have a negative slope, your line should be decreasing, just like this line is right here. Okay, and so if we want to talk about what happened to the graph, there are two things that happened. It is steeper because the slope changed. From 1 to a 2. It's actually a negative 2, but when you're talking about steepness, you don't look at positive or negatives. That's important, so I'm going to say it again. When you're looking at steepness, you don't pay attention to whether it's positive or negative. The negative just tells you it's decreasing as opposed to increasing. It doesn't mean how steep it's increasing or decreasing. So just look at the value. And so the slope value changed from a 1 to a 2. And then the second change is that it changed from increasing to decreasing. And so the way they say that on the star is they say it changes direction. Or they may even say reflected. And so it's changing direction from increasing to decreasing. It's going down the mountain now. Okay? And so for example 3, I'm going to restart the video one more time. All right, example 3, last example we're going to do for homework. So once again, we are starting with the parent function. Slope is 1, y-intercept is 0. Okay, and then for m of x, slope is 1/2. Y-intercept is negative 3. Okay, so y-intercept at negative 3, and then we rise 1, run 2. Rise 1, run 2. You can go down 1, back 2. And so there's m of x. And so when we're talking about what happened to this graph, the first change we notice is that the slope changed from 1 to 1/2, and that resulted in a less steep or a flatter graph. I'm using the words less steep because that's what they say on the star. And so less steep. M of x is less steep. And then the y-intercept has moved down. So not only is he less steep, he has been shifted or translated down 3 units. Okay, no change in direction because both have positive slopes and both are increasing. All right, so as a quick summary of what we've discovered on these 3 examples, I'm going to write over here. Let's get black. So summary. we know that y equals x is the parent function for linears. He is the linear parent function. His slope is 1. His y-intercept, 0. And so if we're looking at a transformed function, we have to look at two things. We first need to look at the slope. For the slope, if it's greater than 1, or greater than any other line we're comparing it to, it's going to be steeper than the parent. And so if we were comparing slopes of 2 and 7, the slope of 7 would be the steepest. And so I'm going to get rid of the greater than 1 and just say if it's greater than whatever you're comparing it to, it's going to be steeper. And remember, you don't look at negatives. If it's smaller, it's less steep, and that makes sense. And so let me do better than that. Okay, and so an example of a steeper function would be 2. An example of a less steep function would be 1/2. And you could even put a negative on this steep. As long as the value, the absolute value of it is greater, it will be steeper. And then if it's negative, that's how you know it changes direction to decreasing. That's where the negative comes into play. So ignore all negatives unless you're talking about the direction. They put that question on there a lot, trying to trick you. A slope of -7 would be much steeper than a slope of +3. The other thing we need to look at is the y-intercept. I'm going to do a different color. And that tells you if it's been translated or down. So translated up or down on the y-axis. And so when you're comparing two functions, always look at the slope and the y-intercept because they're going to ask about steepness, direction, and location on the y-axis. All right, so now let's look at these next situations. Okay, I'm going to record a video going through all of them, but I encourage you to pause it and try some on your own and then click start again to see if you're getting the right answers. Okay, so for right now, we are looking at f of x equals 5x minus 2. Okay, so instead of using the parent function, we're looking at this different function. And so his slope is 5, and his y-intercept, I'm going to use b, is -2. Okay, and so if you change the slope to 3, we're changing the 5 to a 3. Okay, and so what effect does that have on f of x? Well, if we change it from a 5 to a 3, it's getting less steep. Okay, the smaller the absolute value of the slope, the less steep it's going to be. We didn't change the y-intercept, so the only thing that happens is it's going to be less steep. Okay, looking at 5x minus 2 once again, same slope. Slope is 5. Y-intercept is -2. And this time we're changing the y-intercept to 3. So we are changing it from -2 to 3. And so on a graph, it's going from -2 right here to +3 up here. And so in that case, it has been translated or shifted up 5 units. Okay, if you need to, sketch that picture real quick. Don't try to just do the algebra. From -2 to +3, it's translated up 5 units. Don't say 1. All right, number 3, we're starting with a different function where the slope is 5 and the y-intercept 5. I was looking at the previous one. The slope is 7, y-intercept is 6. What would be the new equation if it was translated down 3? Well, if we're moving it down 3, that is not going to affect your slope. Slope is steepness. The y-intercept is what changes when you move it down 3. And so we need to subtract 3, and it changes our b value to 3. And so to write our new equation, we would still have the 7x. Do not change that slope because we are just shifting it down 3. And so instead of +6, we're now going to have a +3 as our new equation. You can use the variable y right there, or you could say g of x or h of x. You can use any letter to name the function you want. Okay, now we are starting with f of x equals x minus 3. So be careful on this. A lot of people get confused when there's no number. Remember, there's an invisible 1. So the original slope is 1. The original y-intercept is -3. Don't lose your negatives. What would be the new equation if the line was translated down 2? Again, that affects our b value, and so we are subtracting 2, giving us -5. If you're in debt 3 and you spend $2 more, you're now in debt 5. And so once again, do not change the slope because we are not changing steepness. So leave it as 1x. You just have to write x and then the -5. Okay, and so I'm going to restart the video. I encourage you to try 5 through 8 on your own and then click the next video to see the answers. All right, let's look at 5 through 8. Okay, on number 5, the original slope is -5. The original y-intercept is -7. Again, don't lose your negatives. What would the new equation be if the line was translated up 3? Again, that is your b value. That is your y-intercept. We have to add 3. And so that gets us to -4. If you take -7 and shift it up 3, it puts you at -4, less negative. And so our new equation would have the exact same slope of -5. Don't change that because we're not changing steepness. But now our y-intercept would have a -4. Okay, number 6, we are starting with a slope of 7, a y-intercept of 6. What would the new equation be if the slope was increased by a factor of 2? Circle that word a million times. Factor, that means multiply. Anytime you see factor, you think multiply. So if the slope is increased, the slope, that's our m value, by a factor of 2, we have to multiply it by 2, changing it to a 14. This time we leave our b value alone. That 6 does not change. The 7 is the only thing that changes because only the slope is changing. And so my new equation would have a 14 as the slope and then still have the y-intercept at 6. Don't multiply that one. Don't add 2, don't do anything, but multiply the slope by 2. You can see how there would be a lot of good distractor options on a multiple choice test for these. Okay, number 7. We are starting with a slope of 4 and a y-intercept of 6. What would happen if the 4 is changed to a negative 10? And the 6 is changed to a 2. So 4 is changed to negative 10, 6 is changed to a 2. So if we rewrite the new equation, you could even type it in your calculator if you want to. Our new slope is negative 10. Our new y-intercept is positive 2. And so comparing it to the original, the slope is now negative, so the first change I can say is it changes direction. To decreasing. It is now a decreasing line, so it changes direction all because of that negative. Okay, the next change is it's changing from a value of 4 to a value of 10. So it is also steeper. A lot of people would say this is less steep because negative 10 is less than 4. Remember, ignore negatives. Negatives just tell you the direction. So it is actually steeper. A steepness of 4 changes to a steepness of 10. It is steeper. And then lastly, the 6 changing to a 2. That's moving down 4. So 3 transformations have happened here. It changes direction to decreasing, it is steeper, and moves down 4. So I actually want you to try number 8 on your own, and then you can come back to this video to check and see if you got it right before we continue on. All right, looking at number 8, hopefully you tried this one. Looking at our original function, we are starting with a slope of 3, a y-intercept of negative 1. What would happen if the 3 is changed to 1/3? And then the negative 1 is changed to an 8. Okay, the change to a 1/3 would make it less steep. And then the change of b value from negative 1 to 8 moves it up 9 units on the y-axis. You could have also said it translated up 9 units. Okay, for 9 through 11, we're just comparing two functions. And so this is when we want to look at the slopes and the y-intercept. Number 9, we're looking at f of x equals 5x plus 6 and comparing it to g of x equals 2x minus 5. So I'm going to start by analyzing their slopes. 5 goes to 2. And so part A asks about the steepness, and so that's how I know I want to look at the slope. Slope is steepness. Think of skiing down a slope. You care about the steepness of that slope when you're skiing. Okay, so steeper or less steep. It started at a 5, and then we changed it to a 2. And so this one got less steep. The slope value decreased, And so it is less steep. Okay, for this one, it says, did the function translate up or down? That's when we look at the b value, the y-intercept. So it started at 6, and it changed to a -5. That moves down 11. Down 11 units. That moved quite a bit. Think of how that looks. -5 is way down here. +6 is way up here. Okay. Number 9, we are comparing 2x plus 6 to -2x minus 5. Okay. And so for steepness, we're looking at 2 and -2. The steepness did not change. Remember, we ignore the negative, so all it did was change directions, but the steepness level would still be 2. Both slopes are 2, and so for this one, neither stayed the same, and that will be an option. The steepness stayed the same even though the direction changed. For the y-intercept, 6 goes to -5. So once again, that's down 11. They could have switched that up for us. Okay, I want you to try 11 and 12 on your own, and then you can come back and check to see if you got them right. All right, last two. We are comparing f of x equals 2x minus 5 to g of x equals 6x minus 5. Starting with the steepness, that means we are looking at the slopes. And so a 2 changes to a 6. And so that is steeper. That is quite a bit steeper. Steeper. Okay, did it translate up or down? That's how we know we are looking at the y-intercept. Starting at -5, goes to -5, neither. Stayed the same. Same y-intercept. So it did not move up or down. The only thing that changed on this function was the steepness. All right, number 12, we are looking at the linear parent function. They love to throw that one in there because they know students don't remember that the slope is 1 and the y-intercept is 0. So the parent function is graphed on a coordinate plane. The graph of the new line is formed by changing the slope of the original line to 2/3, and then the y-intercept to a -8. So slope is 2/3, y-intercept is now -8. So over here, slope was a 1. The linear parent function has a slope of 1, and it is changed to a 2/3. For the y-intercept, the b value starts at 0, which you didn't see, but changes to a -8. And so question A, did the y-intercept increase, decrease, or not change? Well, the y-intercept decreased quite a bit. It decreased by 8 units. Decreased by 8 units. It went down 8. Did the new line G, I guess they're naming it G, the new line G get steeper, less steep, or did the steepness stay the same? Well, if we change a 1 to a 2/3, 2/3 is smaller than 1. So it is less steep. 2/3 is smaller than 1. So the steepness got smaller, it is less steep.